Respected viewers, let us observe. I've got two squares to be colored. Now this can be done in two ways. For example, I've got red and black. This could be red and this would be black. Red and black. Just symbolically written here. 1, 2. 1 stands for red and 2 black. Now we can interchange this. The first one could be black and the second one could be red. So black and red. So in number system, 1, 2 is 12 and 2, 1 is 21. The order is very important. If you interchange the position, the meaning will change. So that is what here. Red, black and black, red different. Now we will do a little bit of observation. Now this first box could be done in two ways. Because we got two colors, you could do either red or black, two. Once you fix this one, only one color will be left over. That's why it could be done only in one way. So the first box could be done in two ways. The second one could be done in one way. That is our observation. Now total number of arrangements, 2. That 2 we are interpreting like this. 2 times 1 is 2. 2 times 1 is 2. We got two numbers, 2 and 1. We have 4 binary operations: addition, subtraction, multiplication, division. 2 plus 1 will not give you 2. 2 plus 1 is 3, so it will not give you 2. 2 minus 1 will give you 1, so that you won't get this result 2. I want this result to be 2. 2 times 1 is 2, yes, only multiplication. 2 divided by 1 is 2. Okay, now we have two options. Is this 2 multiplied by 1 or 2 divided by 1? Because both comes out. Okay. Since we developed a little bit of confusion, let us do one more experiment. This is how formulas are created. Okay. Now we got 3 squares. 1, 2, 3. As usual. Now I've got red, black and green. The first one could be red. The second one could be black. The third one green. And keeping the first one red as it is, I can interchange these two. So it could be green and red. So 123, 132, they are different positions. Once you interchange the position, meaning will change. Yes, the order is very, very important. 1, 2, 3. The first one, the second one, third one. So I'm keeping red here. I've got now 2 possibilities. Similarly, when I keep black here, I've got 2 possibilities. If I keep green here, I've got 2 possibilities. In other words, the first box could be done in 3 ways. You've got 3 colors to start with. It could be any one of these 3. Once you fix this one, only 2 colors are left over. Once you set 1 color, only 2 colors are left over. Therefore, the second one could be done in 2 ways. The third one could be done in only 1 way. Now, we got an option. 3 plus 2 plus 1 is 6. Yes. 3 times 2 times 1 is also 6. Now look at here. 1 plus this 2, 4, 6. 2 plus 2 plus 2. So 3 times 2. That's what 6 now. So 1 plus 2 plus 3. 6 and 1 into 2 into 3 is also 6. Again, a little bit of confusion. Okay. It goes with multiplication. multiplication and addition. The previous one, multiplication and division. Now multiplication and addition. So multiplication, it's now repeating. There it was division, here it is addition. When we do one more experiment, then we will be perfectly alright. Look at here, 4 colors. I've got 4 squares. Now this could be done. I've got 4 colors here. 4 colors. The first one could be, as we already discussed, if I keep red here, the second could be black here. So red is kept here. Now second one could be black. We've got 2 possibilities here. Green, 2 possibilities. Blue, 2 possibilities. 1234, 1243, they are different. 1334, 1342, 1423 and 1432, all are different. Okay, in 6 ways we can do it. Now if you keep 2 in the first position, again another 6 ways. 3 in the first position, another 6 ways. 4 in the first position, 6 ways. This is practical. There is no doubt regarding that. So 6 plus 6 plus 6 plus 6, totally 24. Okay. Now we got 4 numbers. Here I've got 4, 3, 2, 1. 4 plus 3 plus 2 plus 1 is giving 10. We are supposed to get 24, so plus is ruled out. 4 divided by 3 divided by 2 divided by 1, it will not give you 24. So that you could try and answer. 3 divided by 2 divided by 1, it will not give you 6. So division is ruled out. Multiplication is the only option. Now we are confirming here. So here 4 plus 3 plus 2 plus 1 is wrong. 4 minus 3 minus 2 minus 1, that is also wrong. 4 times 3 times 2 times 1, yes, 24. 4 divided by 3 divided by 2 divided by 1, that is all. That will not give me 24. So multiplication is the only possibilities. Okay. So the first one could be done in 4 ways. The second one could be done in 3 ways. The third one in 2 ways. The last one in 1 way. So our formula, we have created a formula. All the 4 boxes can be simultaneously done in 4 into 3 into 2 into 1. These are known as arrangements, or you got another name to call. It's known as permutation. Permutation or arrangements or permutations. Okay. So with 4 objects we have 24. Now that is, we got here 6 plus 6 plus 6 plus 6, 6 plus 6 plus 6 plus 6. Look at here, 6 plus 6 plus 6 plus 6 is 4 times 6. 4 times, the 6 could be written as 3 times 2, and if you multiply that by 1, the result will not change. So 4 times 3 times 2 times 1. From here we are confirming multiplication is the only operation to be followed. And therefore, if you have 2 things, it could be done in 2 ways. Here and 1 way, so 2 into 1, 2. 3 into 2 into 1. 4 into 3 into 2 into 1. Supposing we have 5 objects, so let me include this also. 5 colors I've got 5 colors. The first one could be done in 5 ways. The second one could be done in 4 ways. The third one could be done in 3 ways. And the fourth one, 2 ways. The last one, 1. All the 4 squares can be simultaneously colored in 5 into 4 into 3 into 2 into 1. So 5 into 2 into 3 into 1. 5 times 4 is 20. 3 times 2 is 6. And 20 times 6 is 120. If you have 5 objects, you can do it in 120 ways. Supposing you have 6, the first one could be done in 6 ways, the second one could be done in 5 ways, the third one could be done in 4 ways, the fourth one would be 3 ways, then 2, and then 1. So all these could be in 6 into 5 into 4 into 3 into 2 into 1, 720 ways. So we can further develop like this more and more. Supposing you have 16 objects. The first one could be 16, the second one could be 15, 14, 13, 12, it goes on till 1. Till we reach 1, it goes. So 16 times, 15 times it goes till 1. That is what the beauty. Okay. Now, they are introducing a short form for this. 5 things. First one could be done in 5 ways, the second one could be done in 4 ways, third one could be done in 3 ways, 2, 1. So 5 times 4 times 3 times 2 times 1. So 5 times 4, 3 times 2 is 6 now. 5 4s are 20 times 6 into 120. Okay. Now, our ultimate goal is to save space, energy, time. If I write 1 times 2, I am taking so much of space. I want to reduce the space. 1 times 2, I am wasting energy and time also. So in order to save space, energy, time, I am introducing a new notation. It's known as factorial 2. We call this as factorial. This L-shaped mark is known as factorial. So 1 times 2 times 3 is factorial 3. 1 times 2 times 3 times 4, we say factorial 4. 1 times 2 times 3 times 4 times 5, we say factorial 5. Okay. This is the new. So another notation, when I do like this, L shape, again I am wasting time. Why don't I give another technique? So we do like this, 5 an exclamation mark, 4 this is also factorial, another notation. Again further we are saving time. So 5 factorial, 4 factorial, 3 factorial, 2 factorial. Thank you.